Assalamualaikum warahmatullahi wabarakatuh, and hi. My name is Muhammad ADIB AFIFI bin ABDULLAH. My metric number is 294347. So, first thing first is, I want to discuss and explain about the first question, which is how to summarize the steps for solving the LP model graphically. So, the first step is problem definition. Define the objective function in words and define the constraint as inequalities. Second step, graph the constraints. Graph each constraint as a linear equation in the coordinate plane and shape the region that satisfies all the inequalities. The third step is identify the feasible region. The area where all the constraints are satisfied is the feasible region. Step 4, finding corner points. We need to identify the verticals or corner points of the feasible region. Step 5, objective function evaluation. Plug the coordinates of the corner points into the objective function and complete. The last step, we need to optimal solution. Identify the corner point that gives the maximum or minimum value of whichever is the goal. So you guys can see the example as I provide in the panel. Now we go to the question 2, which in the graphical analysis of a LP model, what occurs when the slope of the objective function is the same as the slope of one of the constraint equations? So my answer is, if in the graphical analysis of an LP model, the slope of the objective function is the same as the slope of one of the constraint equations, then the objective function and the constraint line will be parallel. It simply means that the constraint does not uniquely determine a single optimal point along that line. Therefore, if the constraint line intersects partially with the boundary of the feasible region, there can be more than one optimal solution. This is because, in such a case, the objective function attains the same optimal value for all the points along the intersecting piece, and hence, there are infinite optimal solutions. However, if the constraint line is outside the feasible region or is non-binding, it does not affect the solution, and there will be no more multiple optimally.
Hi, my name is Muhammad ADHA. In this part, I will explain about what are the limitations of the graphical method for solving linear programming problems. There are several limitations of the graphical method, which is, first, it only works for two variables. This method can only handle problems with two variables, like x and y, because we can only draw two dimensions on the graph. Secondly, hard to use with many constraints. If there are too many conditions, the graph will get messy and it becomes difficult to find the area where all the rules are satisfied. Thirdly, it is not for complex problems. Most real-life problems have many variables and rules. The graphical method doesn't work well for this because it's not designed for high complexity. Fourthly, it only works for straight line rules. The method only works if the rule and goals can be represented as a straight line. It can handle problems such as curves or nonlinear problems. Lastly, it is very time consuming. The graphical method can be slow because first we need to do manual plotting. Each constraints need to be drawn as a straight line on the graph, which can take a lot of time to draw if it has multiple constraints. Secondly, shading feasible regions. Identifying and shading the area that satisfies all the constraints require careful attention, and mistakes can be happen easily. Next is finding intersection points. For precise solution, you often need to calculate the exact coordinate of where constraint line intersects, which is it involves solving equation manually. Moving to the next question, which is, what are the benefits of the graphical method for solving linear programming problems? As we learned, there are several benefits that we could get, which is, First, visualization. The graphical method shows the area where all the constraints overlap, making it easier to see how the constraints interact. It also helps shows how changes in the rule or goals affect the solution. Secondly, finding the feasible region. This method clearly shows which part of the graph meet all the conditions at the same time. The area of possible solution is usually formed by the lines where the constraint meets. Thirdly, easy to understand. For problems with only two variables, graphical methods are simple and require only little advanced math, making them accessible to most users. Next is finding the best solution. By drawing the objective function on the graph, it becomes easier to see where the best solution is. Usually, the best solution is where all the intersection of constraint, and this simplifies finding the maximum or minimum value. Next is understanding constraint and limits. Graphical methods clearly show how different constraints shape the solution area. This helps identify which constraints are actively restricting the solution and which one are not limiting.
For question 5, which in the graphical solution method, explain how a constraint and the objective function are plotted on the graph. So I have some ideas to answer this question. My answer is, for graphical solution method, in this method, all the constraints and the objective function are plotted on the graph to identify the feasible region and find the optimal solution. Each constraint is shown as a straight line where the inequality is changed to an equation for the constraint. This line divides the plane into two regions. One region satisfying the inequality and the other not satisfying it. The feasible region is the area of all the overlapping constraints and is usually shaded to show the set of feasible points satisfying all inequalities. The objective function, say, is graphed by converting it into an equation and drawing lines representing different values of isocos lines. These are parallel and indicate the direction of increase or decrease of the objective function. The aim is to identify the highest or lowest point of the objective function's line that falls within the feasible region. The optimal solution can therefore be identified by checking each corner point in the objective function and then picking that one which either maximizes or minimizes the objective, as may be appropriate in the specific problem. That's all my answer for question 5.
A linear programming model, the feasible solution area is the shaded region on the graph where all constraint and non-negativity conditions x1 greater than 0, x2 greater than 0 are satisfied. It is formed by the intersection of constraints, lines, and is always convex, ensuring any line segment between 2 points within the region also lies inside. This area represents all valid combination and decision variables x1 and x2, which is the optimal solution. Maximizing or minimizing the objective function is typically found at one of the vertices of this region.
Moving to the next question, question 7. How is the optimal solution point identified on the graph of a linear programming model? The optimal solution of a linear programming model is identified on the graph as the point within the feasible region that maximize or minimize the objective function. To explain that, I will explain on how to find it. Firstly, plot the feasible region. Graph all the constraints as straight lines, shade the regions that satisfies all the constraints. This we call as feasible region. Secondly, draw the objective function line. This represents the objective function, such for example, z equal to x tambah by. As a straight line for a set specific value of z, this line is typically moved parallel to itself across the graph. The third step is find the extreme point. The feasible region's vertices are the key candidates for the optimal solution. These points are found where all the constraints intersect. Fourthly, Evaluate the objective function. Substitute the coordinate of each corner point into the objective function to calculate the value of Z. Lastly, the point that gives the highest value of Z for maximization or the lowest value of Z for minimization is the optimal solution. As I shown in the graph above, the lines represent the constraint x plus 2.
For last question 8, the question is, in the graphical analysis of linear programming problem, how does the determination of a solution differ between a maximization problem and minimization problem? We have three how to differ it. In a linear programming problem, the solution differ between maximization and minimization based on the objective function interaction with the feasible region. The first one is objective function direction. Maximization, move the objective line outward away from the origin to find the highest Z. The optimal solution is at the farthest vertex of the feasible region in the direction of increasing Z. For minimization, move the objective line inward toward the origin to find the lowest Z. The optimal solution is at the closest vertex of the feasible region in the direction of decreasing Z. Second, key differences. Maximization, the objective line move outward to the farthest point of the feasible region. Minimization, the objective line move inward to the closest point of the feasible region. Third, the example. For maximization, for Z equal to 3x1 plus 2x2, maximize Z by evaluating corner point. For example, in the picture, x is 2, y is 2, where Z equal to 10. For minimization, for Z equal to 3x1 plus 2x2, minimize Z by evaluating corner point. Example, x0, y0, where Z is 0. In both cases, evaluate Z at the vertices to determine the optimal solution. Thank you.